this episode, we are looking at a topic that can sound more advanced than it really is when you first hear it. Scripting and automation are not only for programmers or security engineers working on large systems. Even in basic support work, technicians use small scripts and simple automation to save time, reduce repeated typing, gather information, and perform common tasks in a more consistent way. That matters for A-plus learners because support work often includes the same kinds of steps over and over again, and doing those steps manually every single time can be slow, tiring, and easy to mess up. At the same time, automation is not automatically safe just because it is fast. A script can help a technician do good work more efficiently, but it can also spread mistakes quickly if it is trusted too easily or run without understanding what it will do. The real lesson is not to fear scripts and not to worship them either. The real lesson is to understand what they are, why they are useful, and why careful use matters. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. A script is simply a text file that contains instructions a system can follow. Instead of a technician typing each step one by one every time, the script can perform those steps in the order written. In a support setting, that can be helpful for tasks such as checking system information, mapping a network drive, clearing temporary files, launching approved tools, collecting logs, or helping with routine setup work. Automation is the larger idea behind this. It means using technology to perform repeated work with less manual effort. For beginners, it helps to think of automation as a way to reduce repetition and make routine support work more consistent. If the same safe task must be done many times, a script can help make sure it is done the same way each time. That does not replace technician judgment. It simply gives the technician a faster and more repeatable way to handle common work, as long as the script is understood and used carefully. One reason scripting matters so much in support is that repeated manual steps create opportunities for small mistakes. A technician may forget one step, type the wrong path, open the wrong tool, or skip an important check while moving too quickly through a familiar task. When work is repeated often, even tiny mistakes can waste time and create confusion. A simple, approved script can help avoid that by following the same sequence every time. This is especially useful when a team wants routine work to be done in a predictable way, no matter which technician is handling the issue. A script can also reduce the amount of time spent on boring support steps, which leaves more attention for troubleshooting, communication, and decisions that still need a human mind. The danger, of course, is that consistency works both ways. A good script repeats a good process well, but a bad script repeats a bad process just as quickly. That is why safe use matters as much as convenience. Different operating systems and support environments use different script file types, and A-plus learners should become familiar with the most common names and what they are generally used for. One common example is the batch file, often seen with the extension BAT. A batch file is commonly used in Windows environments to run a series of command line instructions in sequence. Another common type is the PowerShell script, which often uses the extension PS1. PowerShell is widely used in Windows administration and support because it can gather system details, manage settings, and automate many routine tasks. Visual Basic Script, VBS, may also appear in some environments, usually with the extension VBS, and it has been used for automation in older Windows support situations. The main point for beginners is not to memorize every advanced feature. It is to understand that these file types are different containers for instructions, and technicians may encounter them while performing everyday support work. On systems that use Unix-like or Linux-style tools, technicians may also encounter shell scripts, often using the extension SH. A shell script can automate tasks in environments where command line tools are common, such as checking files, moving data, gathering status information, or helping with routine administrative work. Python scripts, often using the extension py, are another example of common automation tools because Python is widely used for general-purpose scripting and can be used to collect information, process data, or support simple automation. JavaScript, often seen with the extension JS, may also appear in certain environments, Although beginners should remember that the same extension can show up in different contexts and should not be trusted automatically. The exact file type matters less than the habit of recognizing that scripts are instruction files with real power behind them. If a technician sees a file that can run commands or perform actions, that file should be treated with attention and caution, not just clicked without thought because it looks familiar. It is also helpful to understand what technicians usually want scripts to do in day-to-day support. Many support tasks are repetitive, and that makes them good candidates for automation. A script may collect system details such as host name, network settings, storage information, or operating system version, so the technician does not need to gather each item by hand. Another script may launch approved support tools in the right order, map a shared resource, clean temporary data, or help prepare a newly issued device. In some teams, scripts are used to standardize log collection so that the same useful files are gathered during troubleshooting each time a certain kind of problem appears. The important point is that support scripts are usually meant to save time, reduce repetition, and improve consistency in work that happens often. They are not magic, and they are not a substitute for understanding the system. They are simply one way to make routine actions more efficient when used correctly. A beginner should also understand the difference between using a script and understanding a script. It is easy to fall into the habit of treating scripts like mystery tools that someone else created and that somehow fix things. That mindset is dangerous because the technician may run something without knowing what it changes, what it deletes, what it collects, or whether it should be used in the current situation at all. Good support work requires at least a basic understanding of purpose before execution. A technician should know what the script is supposed to do, what environment it is meant for, what conditions make it appropriate, and what side effects it could cause. Even if a beginner did not write the script personally, that beginner should not treat it like a magic button. Trust should come from approval, documentation, testing, and understanding, not from habit or blind confidence. A script that is safe for one system may be wrong for another, and a script that helped last week may be risky today if conditions have changed. This leads directly to one of the biggest lessons in this topic, which is that automation can save time, but also multiply mistakes. If a technician performs one bad step manually, the damage may be limited to one system or one action. If that same bad step is built into a script and used across many devices, the problem can spread very quickly. That is why automation should make technicians more careful, not less careful. Before running a script, the technician should think about scope, purpose, and expected outcome. What will this touch? What happens if it fails halfway through? Does it only gather information, or does it also change settings or remove data? Is this the approved version, or just a copy from an old folder with an unclear history? Safe automation depends on asking those questions before execution, not after something goes wrong. For beginners, this is a key mindset shift. Fast actions need more discipline, not less, because speed increases the size of both success and failure. Safety also means being careful about the source of a script. A file sent by email, downloaded from a random site, copied from a discussion board, or shared casually by another user should not be trusted just because it looks helpful. Scripts can contain harmful actions, hidden actions, or poorly written actions that create problems even if the original intent was good. This is why organizations usually want support technicians to rely on approved scripts from trusted internal sources rather than grabbing whatever seems convenient from the internet or from an old message thread. Even when a script came from inside the organization, it still helps to know whether it is current, tested, and meant for the task at hand. Beginners should build a habit of asking where the script came from, whether it is approved, and whether there is documentation explaining its use. Trust in support work should be based on process and review, not on guesswork. A script is still software, even if it is small, and small software can still cause large problems. Permissions are another important part of safe scripting. Some scripts run with ordinary user rights, while others may require elevated privileges to change settings, install software, or affect protected parts of the system. That matters because the higher the permission level, the greater the potential impact if something goes wrong. A beginner should never assume that needing administrator access makes a script more legitimate. In fact, higher privilege should make the technician more cautious. If a script runs with strong permissions, the technician should be especially sure that the script is approved, understood, and appropriate for the task. The same thinking applies to user accounts and credentials. Scripts should not encourage careless password handling, hard-coded secrets, or unsafe shortcuts that expose account information. Support work should always follow the least privilege idea, which means using only the level of access actually needed. A script that demands more power than the task requires should raise questions, not automatic trust. Testing is another habit that separates safe automation from reckless automation. A script should not be treated as safe just because it worked once or because someone said it works fine. Good teams test scripts in controlled ways, especially before wider use. That may mean trying the script on a non-critical device, checking what it changes, confirming what output it creates, and making sure the result matches expectations. Beginners do not need to become software testers, but they do need to understand the simple idea that checking first is better than repairing later. Testing also helps reveal whether the script still fits the current environment. Systems change, software versions change, file paths change, and a script that once made perfect sense may later produce confusing results or fail in unexpected ways. The more often a script is used, the more important it becomes to know that it still behaves properly. Safe automation depends on proof, not on old assumptions or repeated habit. Documentation also matters with scripting, because a useful automation tool becomes much more valuable when people know what it does, when to use it, and when not to use it. A script without context can become a support problem of its own, especially when the person who created it is no longer available to explain it. Good documentation can be simple, but it should answer a few basic questions. What is the script for? What systems is it meant to support? Does it only collect information, or does it also make changes? What output should the technician expect? Are there special cautions, required permissions, or rollback steps? When this information is recorded clearly, other technicians can use the script more safely and confidently. When it is missing, people start guessing, and guessing is not a strong foundation for automation. Beginners should see documentation as part of the tool, not as separate paperwork. If a script matters enough to use, it matters enough to describe clearly. Another important idea for new technicians is that scripts should support thinking, not replace it. It is tempting to believe that once a task is automated, the technician can step back and stop paying attention. But support work does not work that way. A script may gather information faster, but the technician still has to interpret the results. A script may perform a routine cleanup, but the technician still has to decide whether the cleanup is appropriate for the current issue. A script may help with setup, but the technician still has to confirm that the setup succeeded and that no side effects appeared. Automation reduces manual effort, but it does not remove responsibility. In fact, responsibility becomes more important because the script can act quickly and quietly. Beginners should learn to stay mentally present while using automation. Watch what happens, compare the result to what was expected, and be ready to stop, review, or escalate if something looks wrong. Safe automation still needs an alert technician behind it. A simple example makes this easier to picture. Imagine a support team has a small PowerShell script that collects basic network details, device name, operating system version, and recent log information when a user reports a connection issue. Used properly, that script can save time and make troubleshooting more consistent because every technician gets the same useful information without manually collecting each item. But now imagine the same script is outdated, runs on the wrong kind of system, or includes a cleanup step that removes files the team actually needed to review. In that case, the speed of the script becomes a problem rather than a benefit. Or imagine a technician receives a batch file from an unknown source that promises to fix a login issue instantly. If that file is run without review or approval, it could change settings, expose data, or create a larger incident. These examples show the real balance beginners need to understand. Scripts are helpful tools, but they should be treated like powerful tools, not harmless shortcuts. By the end of this topic, the main lesson should be clear. Scripting file types such as BAT, PS1, VBS, SH, PY, and JS are common ways that technicians automate support work, and the reason they use them is simple. Automation saves time, reduces repeated typing, and helps routine tasks happen more consistently. But those same strengths create risk when scripts are trusted blindly, run from unapproved sources, used with unnecessary privileges, or applied without understanding the result. For A+ learners, the goal is not to become expert script writers right away. The goal is to become safe and thoughtful users of automation. A good technician knows that a script can be helpful without being magical and powerful without being trustworthy by default. When you approach automation with that mindset, you get the benefit of speed and consistency while still protecting users, devices, and the organization from avoidable mistakes.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.